Hello, everyone. Welcome to today's webcast, Introduction to Automated Testing in Modern Data Architectures. We're going to get started with some quick introductions of our team on the call. So my name is Scott Stieritz. I work out of Thorogood's Philadelphia office, and I'm joined today by my colleague Nanda Kumar Naindurai, who's based out of our London office. Nanda and I are both business intelligence and analytics consultants with Thorogood, and we both bring to the table experience from a number of BI and analytics initiatives across a variety of industries, including solutions in which we've implemented automated testing practices. You can also feel free to get in touch with us via our contact details that are up on the screen right now. And at the end of the webcast, we'll again loop back and share those same details. So before we get going, we'll take a quick look at today's agenda. We're going to start off with an intro to Thorogood and what we do, and then we'll talk about software testing at a high level, followed by looking at automated testing more specifically, including what it is and why we should bother with it. Next, I'll hand it over to Nanda for a more specific look at automated testing within modern data architectures in BI and analytics solutions, after which he'll take us through a demo, and then we'll wrap up for the day. So like I said, we'll kick off with a very quick intro for those of you who don't know Thorogood. Thorogood's an independent professional services consulting firm specializing in business intelligence and analytics solutions. Thorogood works as a single organization serving our customers throughout the globe with leveraged teams of consultants in our offices in Philadelphia, Boston, and Sao Paulo in the Americas region, as well as offices in London, Bangalore, and Singapore. All of our consultants across all of those offices are recruited and trained in the exact same way to help us develop a unique mix of skills in which we can blend business understanding, technical aptitude, and a deep understanding of analytical tools and techniques that are available. We as Thorogood offer a full range of services within BI and analytics, everything from strategy and roadmaps to recommending and designing architectures, designing specific solutions and implementing those solutions, as well as offerings like data and analytics services and support for production applications. And we have some BI and analytics focused products as well. We've also supported our customers in initiatives like user training and user empowerment. Our clients typically span 4 data-rich verticals, which are consumer goods and manufacturing, pharmaceutical and health services, banking, and insurance. Our clients are some of the leading organizations in these sectors, as well as in a couple other sectors, and we take a lot of pride in some of the long-standing relationships that we have with a number of the organizations that I have up on the screen right now. So what types of technologies do we work with? Well, we're an independent consulting firm, which means that we don't work with one specific technology. Instead, we work and partner with many of the key players kind of across the BI and analytics market in order to make sure that we're bringing to our clients solutions that best suit their needs. We've built solutions that use automated testing across a number of these different technologies, so feel free to reach out if you have any more specific questions. So that was a quick intro. Now we'll look at software testing as a whole. So what is software testing? Well, it's one or more tests that we run in order to measure the quality of a software product or service that we're creating. During this testing, we're often looking at a few key areas, like whether or not the application's implemented design matches the intended design, everything from technical requirements to coding standards, how easy and intuitive the solution is to use for our intended audience, how well the solution performs, so things like response time to end users, some assurance that the solution's environment is configured appropriately and that the solution will continue to behave as expected once it moves to production environments, understanding how the solution handles all sorts of inputs and situations, not just the most common ones. Then lastly, making sure that the solution brings value to the end users. So it's great that it matches the original design. It's great that it performs well, all of that, but it's really only valuable at the end if it truly brings business value. So you want that confirmation as well. So how do we go about doing this? How do we run this software testing? Well, broadly speaking, there are at least 4 levels of testing. There's unit testing, where we're looking at individual tool components, integration testing, or making sure the new pieces of development fit with any other existing pieces of functionality. System testing, where we're making sure that the solution as a whole is behaving as expected, and user acceptance testing, in which the end users or a subset of those end users themselves are giving this confirmation that the solution is good and it's bringing business value. And within traditional software development life cycles, we've seen things happen in a kind of waterfall shaped manner, in which each piece of development happens in sequence. So first, of course, is the development itself. Often in a waterfall model, this might mean development of the entire tool or the entire set of intended deliverables all at once. Then we move into unit testing, integration testing, system and user acceptance testing periods, all kind of as individual periods, again, each covering that entire tool or entire set of deliverables. And since these testing periods are traditionally manual testing efforts, there are pretty large functionality that are being tested. Why does this happen? Well, because when we're testing manually, it can be pretty expensive to test at a high frequency in small chunks, since there's a lot of overhead to that manual testing. And what does this mean? Well, it means that there's a long time in between. We think about this development piece way at the beginning, all the way down until when we're finally exposing new development to the users. And even then, they might not like the functionality. They may say it doesn't work for them or doesn't bring appropriate business value. So this waterfall approach can be pretty risky in terms of making sure that we're delivering business value and getting strong business buy-in. It might be reasonable for something that's very small, a very short project in which all the chunks are inherently small, but it's really not a good idea for larger pieces of development, especially in which the tool will be developed iteratively over time. We'll talk about some of these trade-offs in a minute or two. So that was testing in the waterfall world, but what's the alternative? Well, we could also take a look at the agile approach to testing. And this is where testing might happen on a sprint basis, where our goal is to develop a small piece of functionality, run those initial tests quickly, get it to the users quickly, get feedback from those users quickly, and then update the tool accordingly. This is a continuous process, and we're repeating this development and this testing cycle for each chunk of functionality in further sprints. So we're making progress in that we've taken our monolithic effort and split it out into some smaller chunks. And now in order to accelerate our overall project timeline, we need to think about how we speed up each of these individual cycles, or how can we even parallelize these cycles. And this is what brings in scope for applying some of the automated testing practices that we're going to discuss today. So what do these practices look like in theory? Well, first we're going to start with needs. So what do we need out of any testing process? We need to understand requirements, of course. We need to understand what we want to test. We want to define those test cases, and then we want to execute those test cases. So it's pretty straightforward. In the manual testing world, humans are doing all three of these pieces. But what about in the automated testing world? Humans are still, of course, understanding requirements, and they're still conceptually defining what the test cases are. But the difference really comes in when we think about the test case execution. The first thing we're going to need to do for automated testing is define an automated testing framework. Then as the test cases are defined, ideally in step with each small piece of functionality that we're adding to the tool, we're also scripting out those test cases within the defined framework. Lastly, we're taking this framework, we're taking those defined test cases, and we're scheduling or we're automatically executing our scripted testing suite. So if we think about this versus the manual testing effort, really all that's changed is this bottom piece. It's how we're going about executing these tests. So what trade-offs are we implying here, and where are we placing our bets? Pretty simply, we're betting that the technical benefits of automated testing, which we'll look at in a bit more detail coming up, and the speed of automated execution outweigh that initial investment in framework definition and in test case scripting. So like I said, let's think about those benefits. Why bother with automated testing? Well, firstly, it offers us considerable consistency. Within manual testing, there are tons of opportunities for human error and for inconsistency. And although we'd like to think that the answer is yes, can we really say that humans would test the exact same way each and every time? What if you had multiple different groups of testers over time? and anything less than 100% perfect knowledge transfer in between those testing groups? Or what if your manual test suite pseudocode has a little bit of ambiguity in there where people are giving different interpretations to how the test cases could be run or should be run? Or would even the same tester always select the same filters, process the data in the same order, work with the same testing data? Or what if a tester was frankly tired of running the same tests over and over after a ton of successful runs in a single day and decides, okay, I'm just going to test a subset of those test cases. I'm going to skip a couple in order to work a little bit more quickly. If you can honestly tell me that none of those situations are in the slightest bit possible for you, then congratulations are probably in order, but I just don't think that's realistic. Automated testing, on the other hand, offers a defined set of tests that will always run the same way, every single time given the same inputs, eliminating many of these opportunities for inconsistency and therefore eliminating opportunities for bugs. It is important to note that one thing that automated testing doesn't eliminate is the possibility of poorly defining the test cases or accurately scripting the test cases. Remember, those still require manual effort, so we need to be particularly careful when we're doing these things. Another benefit is increasing returns to scale. So we talked about this upfront investment. There's the one-time cost of framework implementation and one-time cost per test case of the test case scripting. But this drastically reduces the incremental cost for each execution of a test case. In other words, we put in a little effort up front to ensure that we can test and retest pretty much as often as we want and as quickly as we want, which enables a culture within our organizations and within our development lifecycle of frequent or almost constant testing, again, giving us more opportunities to identify and eliminate bugs. We can also think about the functionality in a tool getting larger and larger. So the unit test cases, the effort of defining those is generally proportional to the size of the unit. But for integration testing, it more closely tracks with the size of the tool as a whole. And as there's more and more existing functionality as our tool grows, that means there's more and more to recheck to make sure it's still working appropriately. In automated testing, unit tests simply merge right into our integration test suite. So we have code, we've defined this code that ensures that each unit is working appropriately, so we can easily go back to these previously scripted tests for our existing functionality and rerun them every single time we add in new functionality to make sure that they're all still working as expected. On the manual side of things, within manual integration testing, especially for more waterfall projects, we often need to go back and find, if we can find them, the original integration test suites, look at existing pieces of functionality, redefine the test suite, update it, and go through the pretty costly process of manually rerunning each case. Another benefit is progress capture. So let's say that we have a tool that's working well today, and all of a sudden we add on some new functionality, and users are alerting us that not only there are problems with the new pieces, but also in the existing pieces, even those aren't working correctly anymore. So this can sometimes feel like we're not only stagnating, we're not only not making progress in development, we're even losing progress. Within automated testing, the development and testing efforts are no longer separate entities. They're now part of the same code base. And as we had discussed in some of the previous views that we had looked at, full integration tests are now much cheaper and much quicker for us to run. So any new development, which has the potential of compromising existing functionality that we had already developed, already tested successfully, any of these potential issues can be identified immediately and flagged for revision. And lastly, we can integrate much more easily with our CI and CD and DevOps pipelines. So this framework, this automated testing framework, enables taking the testing effort and making it part of the development process itself, allowing us to move much closer to continuous testing, such that each piece of code or functionality that's added or changed or removed from our code base is tested immediately. And we can kind of think of this like building guardrails for ourselves as we develop. It prevents us from straying off course. And in the manual effort, sure, we could define processes that require testing and passing those tests as prerequisites to moving up through environments and deployment, but now we can beat process. We can do this programmatically, in which we're promoting code given a hard dependency on that code, that specific code that we've developed, and the entire tool code base passing all tests before the deployment is allowed. So again, we can get rid of some opportunities for human error or human workarounds, and it also provides a level of traceability to make sure that our production applications are always on and always working. So that was an overview of automated testing conceptually. I'm now going to hand it over to Nanda for putting automated testing in the context of BI and analytics.
Now let's look at some common test cases to consider while implementing automated testing to a technology agnostic modern data architecture, and then we'll look into a quick demo. So just taking a look at the modern data architecture. On the left-hand side, we have various data sources which are loaded into the landing zone, and then the data goes through various stages of transformations in process and output layers. And it could be any number of layers that you might have as part of your modern data architecture. The data is usually enriched with calculations and business logic, and it is loaded into your data mart, which could be either a database or a multidimensional model, depending on the business case that you're looking at. And then this semantic layer is then used by reporting applications like Power BI, Tableau, Looker, or even from a custom web application for business users to consume. Now, what we have here is a series of components, and all of them are expected to work in conjunction with each other for the application to work as expected. What we will explore now is some common test cases in this modern data architecture. So starting from the very left, what are the different scenarios that you would like to test? Is sourcing data flowing into your landing or raw layer? Things like are row counts the same, or the measures aggregating to the expected values? One thing you could do here is like a way of like a passive logging of row counts for someone to have a look at it later, which has been the traditional way of logging. And if things go wrong, the question you need to ask yourself is like, do you want to wait until someone looks at the logs? Or can you think about like creating some sort of an alert mechanism, depending on the severity of the issue, and send notifications to the support team and alerting them to have a detailed look? Next, things like, are transformations applied correctly, and how can you do that by means of like validating if these transformations are applied correctly, by checking if there are no null values, records are not being lost, and etc. The next thing to consider here is about like, are the business calculations applied correctly? You can automate these tests using things like seed databases or test data that you can configure upfront and then can be used as part of your test scripts. And then flowing into your report, you need to sort of test whether your semantic models refresh appropriately, whether the row counts match with the source row counts, and whatever data that you expect to see here is reflected as expected. And from web applications perspective, like, you can test if components render, if buttons and controls are working as expected, and then did the reports actually refresh successfully. Taking a step back, what you also need to sort of consider is like, you need to consider the coding standards. Let's see your code comply with the best practices that you have defined. Are you using any redundant variables? Are there any unused variables and formatting consistency? These things are usually called as linting, and you sort of can automate this as part of your development lifecycle. And then coming to infrastructure, you need to sort of test for security rules, best practices, and also to check whether there are tags being present for components that you define as infrastructure as code for your cloud services. Now, with increasing adoption of DevOps tools and processes, the most common approach is to develop your code or check into a main repository where there is a version control defined. And then code is usually built and integrated with checks being done for syntax, etc. Like I said, the linting process is usually done here. And then you create a release and deploy code to the chosen environment. In the traditional way of testing, before the build and integration takes place, and potentially after development is done, unit testing is performed, and then after deployment, system or regression testing is usually performed. But as you start to consider building an automated test cases as part of your DevOps pipeline, you might have to think about like pre-build and integration. So which is where you check for your linting standards, like following best practices, checking for your infrastructure as code, whether mandatory tags are being present, And then as part of your pre-release, you would want to sort of include tests like taking snapshots of data before a new code build is pushed through, allowing you to compare with results after deployment. And then post deployment, like what you also need to sort of look into is like run a series of checks to validate if your code is working, dry runs of data flow processes, check that models refresh, and if they fail, refresh the deployment and switch back to an earlier build. And all this can be automated. As Scott was saying earlier, there isn't a lot of distinction between unit testing and integration testing anymore. There are test cases for different modules, and with the execution of test cases being integrated into your DevOps pipeline, you are implementing continuous testing within the CI/CD pipelines, and these tests are run as part of each deployment. Also, as part of the initial phase of continuous testing, there needs to be an initial activity around test planning and definition to structure the kind of tests you want to run. There is this upfront activity that is required, and as your application evolves, there will be more test cases that will need to be written as well. So this is a continuous activity that you will have to invest your time on. Now I'll briefly share a business case followed with a demo highlighting some of the concepts we just discussed. Let's state the business objective is to build a reliable data mart using SAP source systems for a supply chain team. And building a data mart by loading data from SAP systems into a SQL database with the required transformation so that handles the data appropriately. Things like snapshots, delta, full loads or partial loads are handled appropriately. And one of the many challenges that we need to address here is that SAP source tables usually have technical names for their base tables like VBAP, LAPS, LAPK, and similarly will have technical column names as well. And one of the objectives is to rename the column names appropriately as part of the data transformations and build a solution that can scale to hundreds of tables across SAP. This is required so that business can build multiple applications on top of the data mart. So just continuing with the previous modern data architecture, what I have here on the source system is SAP, and then all the data is then loaded into landing zone in Azure Data Lake Storage with transformations happening across the layers, landing, process, and output. Databricks is used to transform data across these layers, and Databricks essentially gives an option to write code in either R, Python, Scala, or SQL, right? So one of the design approaches that we would like to exercise here in this example is to build a package solution so that it can be used by citizen data scientists and other developers to directly call those objects to access the SAP tables within Databricks itself. So what we're saying is the data sets are defined as classes using Python code with an object-oriented approach, and then appropriate functions are written for data wrangling purposes. And the code is expected to be highly modularized, and hence the motive here is to reuse across multiple data sets and use cases. So for example, if I do vbas.get, what I expect here is to basically return the return this SAP table contents as I run this, as I execute this line of code. Just going a bit deeper, what I'm sharing right now is a project structure of a mini code base that we prepared exclusively for this demo. So as an extension of the business case that I was describing, we have 3 layers like landing, process, and output. The data mart folder, or what we call as package in Python world, contains all the code base with all the transformation logic written here. As an example, the process layer basically consists of code for each and individual object or table corresponding to SAP source. And then followed by test folder, which consists of all the code for unit test cases that we have written. And then finally, we have a YAML file that has the necessary setting for the Azure pipeline, which we'll go into in a moment. So yes, just looking at the code in terms of what we have on the pipelines. So there are some triggers that are being defined here. Like as I mentioned, the code is currently being maintained in a repository. So depending on the branch that the code is committed to, triggers can be applied here. And then similarly for pull request as well. But the most important thing that I want to call out here is that I have a stage defined here, which says code deploy and testing. And then I have defined 2 jobs, one for code deploy and the other one for testing. So code deploy basically gets the code base from the repository that I currently have my code on, and then gets it into a place where I can, into a working directory where I can access it as part of the CI/CD pipeline that I have currently. And then the second job I want to call out is the testing one, which is where I want to put some emphasis on. So here I have few steps actually here written down. And the first step here, running Flake 8 compliance. So Flake 8 is basically a Python library that can be used for linting purposes, like making sure that your code is structured properly, coding standards are being followed, there are no unused libraries that are present in your code base, that sort of thing. And then we also run a documentation, like building documentation by using Sphinx, which is another Python library which comes in very handy for generating documentation. And then the most important part that I want to call out here is basically the PyTest that we run here as part of the code base that we have here. And what essentially happens here is the PyTest basically runs all the test cases that are defined within the test folder. So all the unit test cases that has been defined to test if everything works as expected is getting run as part of this particular line. And then I have another stage called release stage. I'm not going to go into too much detail about this, but one thing that I wanted to call out here is this stage basically depends on code deploy and testing, the earlier stage that we were just looking at. And this executes only if and only if the code deploy and testing stage actually gets completed successfully. And another condition that we have here is that the branch that we are merging into needs to be either a release branch or a master branch. And sometimes you sort of like need to have control over who has permission to merge your code into release or master branch, and making sure that they are the only people who can deploy into release is something that you might want to have a control over. So now let me quickly switch back to Azure DevOps and give a flavor of how this actually works in action. Some of you might be familiar with this Azure DevOps portal. So what we really have here is a list of pipelines. So the Azure pipelines YAML file that we were just looking into that has been configured as an Azure DevOps pipeline, the automated testing demo one. So what I have done here is basically I have run the pipeline earlier as well. If I just quickly click on edit and show you the YAML file, this basically has the code base that I was just sharing actually. And you can also choose the branch that needs to be used for your pipelines to run. If I quickly look into one of the pipelines that I recently ran, like just a couple of hours back, you can see these two stages here, the code deploy and testing, and then release stage. Release stage was skipped because the code was not actually committed to either release or master branch. And if you go to code deploy and testing, what you can see here is basically the list of jobs that we have defined as part of the Azure pipelines. The first step was to basically deploy the code base to the blob storage and has a number of steps within it. And it also has a testing job under which we have a number of steps defined under it, and the tests are basically run here. And if your tests are not run successfully, it will just flag that it has failed, and the release stage will not go further, and you will get an automated email saying that the build has actually failed. So I hope we have given you a quick overview on automated testing, but that's not all. Frankly, we have just scratched the surface of it, and we will be happy to have further conversations on this topic. Now, looking at some of the other considerations to keep in mind, it is imperative that understanding the business benefits of using automated testing in your use case is the first and foremost priority, which is then followed by defining the CI/CD pipelines that suits your business needs. Next, once you sort of understand the value proposition, you need to understand how and where to apply automated testing effectively. The required tools and technologies in this space are evolving more rapidly. You might want to consider leveraging your existing tools or explore using your existing cloud vendor. Some of the top cloud vendors like AWS, Azure, GCP have their own services for DevOps, or they can be used to deploy multiple third-party tools that are available in the market. And how can we help you? So we are happy to help you with identifying your needs for automated testing, defining the required framework and any setup that is required. And if you do have a project in mind that could benefit from automated testing, let's explore how best to tackle some of the challenges that are on your way. Feel free to reach out to us if you have any questions. Once again, thank you everyone.